In this problem, we're given some information. 0.1 cubic centimeters, so centimeter cube sample of plutonium, it's a metal, weighs 1.98 grams. What is its density? And then, of course, finally we have to answer the question, will it float in water? So the unit for volume is cubic centimeters, the unit for mass is grams, and the unit for density in this case would be grams per centimeter cubed. So grams divided by centimeter cubed. So mass over volume is density. So we are given the mass, we are given the volume, we put one over the other in the form of a fraction, combine the numbers, and get grams per centimeter cubed as the units, because those are the units that are left in the numerator and the denominator. Per because of division. So combining the numbers, we get 19.8 grams per centimeter cubed. Just remember that mass over volume is density, so it's grams per centimeter cubed. That's the unit for density. Now, here's a fact that we need to know. If the density of an object is less than 1 gram per centimeter cubed, then we know that the object is going to float in water. But in this case, the density is 19.8 grams per centimeter cubed, definitely bigger than 1 gram per centimeter cubed. So therefore, this is going to sink in water. In this problem, 8 ounces of whiskey, a hard liquor, would have 70 grams of alcohol. A 200-pound man would have approximately 6 liters or 600 milliliters of blood. If he quickly drinks 8 ounces of hard liquor, and if the liquor or the alcohol in the liquor immediately gets absorbed into his system of 6,000 milliliters of blood, what would be the blood alcohol content? So first we need to know what the blood alcohol content of or how it is measured. It is grams of alcohol, the grams of alcohol per, which means divided by 100 milliliters of blood. So grams of alcohol per 100 milliliters of blood is the way blood alcohol content, BAC, is measured. So if 70 grams of alcohol is immediately absorbed into the system of 600 milliliters of blood, the blood alcohol content can be calculated by having the amount of alcohol in the numerator and the amount of blood in the denominator. So simplifying it completely, we get 70 over 6,000, which is equal to 0.01167 grams per 1 ml of blood. But the blood alcohol content is measured per 100 ml of blood. So we multiply the numerator and denominator by 100, so we are not changing the number. So multiplying the denominator by 100 gives us 100 ml, and that's exactly what we need. And multiplying the numerator by 100 gives us 1.1666, and that would be 1.1666 grams of alcohol per, so that's grams of alcohol per 100 milliliters of blood, which is really 14 times the legal limit, which is 0.08 grams per 100 ml, and that could be fatal. But luckily, the alcohol doesn't get immediately or instantaneously absorbed into this bloodstream. It happens slowly, so it keeps the blood alcohol content at a certain limit. So the next part of the question says that if the alcohol gets immediately absorbed into the system of 6,000 milliliters of blood, but now we're going to add one more condition, which is uh, the rate at which the body eliminates the alcohol. So it eliminates the alcohol at 15 grams per hour. So every hour, 15 grams of alcohol is eliminated. So we are looking at the same person whose blood alcohol content is 1.667 um, grams per 100 milliliters. So he consumes 70 grams of alcohol in his system of 6,000 milliliters of blood. In 1 hour, 15 grams of alcohol is eliminated. In 4 hours, 4 times 15 grams of alcohol is eliminated. So we have 60 grams of alcohol eliminated in 4 hours. So his system of 6,000 milliliters of blood still has 70 grams minus 60 grams, which is 10 grams of alcohol. So 10 grams of alcohol per 6,000 milliliters of blood. Now let's see what that means in terms of his blood alcohol content. So his blood alcohol content can be calculated by dividing the amount of alcohol in grams by the amount of blood in his system. So it's 10 over 6,000 grams for 1 milliliter of blood. But that's not the blood alcohol content. Um, the amount of alcohol per 100 milliliters of blood is the blood alcohol content. So we multiply the numerator and denominator by 100. So this gives us 0.16666 grams per 100 milliliters of blood, which is still twice of what the legal limit is, which is equal to 2 times 0.08, which is 0.8 times 2 is 16, so it's 0.16. It's still twice the legal limit, which is 0.08. So therefore, this person should not be driving after drinking one drink. And all this, of course, is under the assumption that alcohol gets absorbed into the body very quickly or immediately.